Good morning once again, everyone, and thank you for joining the webinar. Our presenters today include Abhay Kulkarni, VP of Engineering at Netskope, and instead of Joe Pavayo, we now have Kumar Saurabh, who is the co-founder and Vice President of Engineering at Sumo Logic. You can submit your questions anytime through the chat window in your control panel, and we will address them in the Q&A session towards the end. With that, I hand it over to Kumar.
Thanks, Asta. So I'm excited to talk to you guys today about how we use Sumo at Sumo, give you a quick background about what we do. And I'm also, as Asta said earlier, I'm excited to have Abhay on the line as well to talk about how Netskope is using Sumo. Right? So with that brief overview, let's dive into what we actually do. So we are a cloud-based log analytics, machine data analytics system. And what we do is collect log data or any sort of machine data, metrics, log data, up and down the stack, right? So if you're running an application, a business critical application, we can get the log data from application layer, or we can dig one level deeper and look at the OS layer. And even many of our customers even use for collecting client-side data from mobile devices or connected devices. Those are some of the newer use cases that people are using Sumo for. But the underlying use case is you have instrumentation data in your apps, devices, servers, applications, bringing all of that data into one place so that we can actually do analysis on the data and be able to search that data. So one of the most common use cases is something bad happens and you want to troubleshoot and do forensics analysis. Once you have all of the data in one place, it's really easy to dig into any layer of the stack and find the root cause and connect the dots and build a story behind as to what actually happened. Once you get to the root cause, many people want to actually monitor it, trend it, and they figure out what are the interesting visualizations that they can put on data. And we'll talk a bit later in the presentation about how we ourselves use our product to visualize operational data at Sumo. But one of the things even better than troubleshooting, monitoring, alerting is the ability to predict and proactively catch events or proactively detect events that you might not have even thought about. But given that we're collecting all of the data, those clues are already in the data. So we'll talk about some of the advanced analytics that we have built over a few years that can help detecting even events that we did not know about, right? So for us, the deployment model is really simple. Our customers start out, once you sign up for the tool, they start out by downloading these small pieces of software that we call Collector, right? And you can deploy it if you're running an on-prem application or you have on-prem IT infrastructure. You can run it in your own infrastructure in a data center or if you're using any of the cloud services and you're running your application in an infrastructure as a service or a platform as a service provider, you can have those collectors right next to your application in the cloud. They can collect all of the data and send it to the Sumo Logic service. And that's all they do. We have a couple of other modes of sending us the data as well. Especially for client-side log collection, we can have an endpoint in the cloud. A hosted collector is what we call it, right? And you can send data to it using simple REST APIs. We even have support for various cloud service providers that we can collect data on your behalf using the credentials that you provide us and collect all of that data and feed into Sumo Logic. Now, as all of the data gets into Sumo Logic, there is a core set of analytics available for you to do. All the data that gets in the service gets annotated, parsed. You can extract fields from those log data and put a little bit of a structure on the fly as the data is coming in. And then all of the data, all of the log data gets indexed so that you can easily search it. It also gets fed through what we call a continuous query engine, so that if you have a trend that you would like to monitor or an error threshold that you're monitoring, you can monitor it live And as every bit of log data is coming in, those trends get updated as we go along. So it's a very real-time analytics that you can have. Very, very useful for doing operational analytics or security analytics, because you want those insights, you want those alerts in real time. And the search and the reporting capability in Sumo is pretty broad. The idea there is, if you have the log data, if you have the machine data, if you have the instrumentation data, and you have a question, you should be able to ask the question and get those answers, get those insights literally in seconds and minutes. And that is the core analytics that you get out of the Sumo Logic service. But over the years, we have built some very custom advanced analytics that are especially suited for the field of machine data. And I would start out by talking with LogReduce, which is something that we have done from day one of the service being launched, because what we realized that log data is so voluminous and there's so much variety in log data. I mean, literally there are hundreds, if not thousands, of log formats. And with more and more DevOps kind of culture taking root, the development teams are pushing new code to production every day, every week, every month. No longer people are waiting for 12-month, 18-month production cycles to push new code out, right? So in that environment, your log patterns are constantly changing. So just being able to parse all of that data and do upfront parsing is not going to scale, is not going to work, and your analytics will constantly fall behind. And that's why we introduced LogReduce. And LogReduce, what it does is it automatically tries to infer the structure behind all your log data. And on top of that, over the last 2 years, we have built anomaly detection. So once we can fingerprint, once we can understand what kind of log data we are getting, we can start building baselines. And we can start looking at the log data that you are getting in the last 5 minutes and compare it to last 6 hours. And when something bad happens, more often than not, the log profile will change. So we can look at the last 5 minutes of log data and the profile of all the log data that's coming in and say that, oh, it looks very different from the last 6 hours. So there must be something interesting going on, and we can give you a heads-up analysis on that. Another thing that we recently introduced that is pretty unique is around transaction analytics. And we'll talk about that in a little bit more detail. Here is a quick screenshot of of how LogReduce works, and it's probably very hard to see, but the amount of search results in just 15 minutes, and this is one of a very small deployment, but we are still getting 3,000 search results. And when you are getting 3,000 search results, instead of going through one by one, you can LogReduce it, you can summarize it. And so what it does, it figures out, oh, 1,800 of them are exactly the same kind of log data. So it puts them at the very top. And then what you start seeing is the long tail of the log data. And we are not showing an exception here. There are some denies, TCP connections, and things like that. When I'm run LogReduce in our application, one thing that becomes very clear is some of the errors and exceptions that might have gotten buried in a lot of data shows up on the first page or the second page. So it magnifies the signal to noise ratio for you so that we can quickly pinpoint the logs that look out of whack or out of order. Now, this LogReduce technology is very useful to condense all of the logs into a few patterns. But what is even more powerful is how it lines up the logs. It literally, the way it works, if there is a printf statement, most of the logs will have a common structure. That's why we call log data not unstructured but semi-structured, because there is a printf statement that is the DNA of that log data, right? So we can line those log data next to each other and infer which parts are changing, which parts are constant, and we can derive a signature from all of that log data. And now, on top of log data, we start building those baselines. So the first step, what LogReduce does is converts logs to signatures, and we can start profiling. We got I don't know, 200,000 logs in last 15 minutes. Okay, what's the distribution of different kind of logs in that mixture? So we can build that baseline, we can build that profile, and then what anomaly detection engine does on top of that, it looks at successive baselines, and the baseline that we built over last 5 minutes, we call it the digest. So it compares the longer term baseline with the last 5-minute digest and picks out places where there are anomalies, and picks out things where there is a lot of deviation from the standard, from the baseline, from what's expected. And it starts turning those things into events. And it will tell you this is an event because these signatures, I only expected 5,000 of those, but in last 5 minutes, I got 65,000 of those. So that will show up as a big anomaly. And there might be a couple of other kind of logs that change at the same time. So it will group all of them together and mark them as events. And you can monitor for those events, or you can set up a scheduled alert. So when an anomaly is detected, it actually gives you an email and someone can take a look into that. This is a quick screenshot of how our anomaly detection engine looks. It is a dashboard, so what we're seeing here is last 6 hours. And the 5, 6, and 1, the color-coded things that you see on the top left are the events that we have already detected and annotated in the past, right? So the first time when it works, it will only show you that blue bar. So blue bar stands for the unknown events. Now, when the anomaly detection engine starts in your environment, first time, it's not going to know about any events. It won't have a database of known events. So every event, every anomaly that it sees is going to be a new anomaly. Now, you can go drill down into those anomalies and you can annotate them. Some might be innocuous, you can suppress them. I don't want to see that ever again. Some might be very high criticality event, and you can say, you know, you mark it as high criticality, and if that event happens again, even if it's slightly different, there is a fuzzy matching going on. So the anomaly detection engine builds a database of known annotated patterns, and then it matches every new event that it catches and says, oh, I've seen this before, so this is a high severity event. And that's how you're seeing here things that are labeled, that are colored red, orange, and green. And it might still detect some anomalies that you haven't seen in the past, and those will show up as blue. And the analyst can drill down into that, dive into the search, do some forensics, figure out whether it's anomalous, whether it's harmful or not, and then annotate it, right? And so let's switch gears a little bit and talk about transactional analytics. One of the common use cases that we got mostly from retailers and security folks, actually, where they want to track a particular IP address or a particular customer through various stages of a flow, right? So you go to Amazon.com, you log in, you go to recommendations page, you look at a few things, you add something to your cart, and then you kind of walk away and never hit the purchase order button, right? So this, what it does, or you can be an attacker, you come through, you know, you scan the perimeter, you manage to get through the perimeter, you scan some vulnerable printers, and then you try and exploit on those printers, and then you're scanning every other system in the network, right? So those are all the kind of things where it's a flow, it's a transaction, it's one person doing a bunch of things that are connected. So that's why we introduced this transaction analytics, which you can identify these various stages, you can define these various stages, and you can see how an IP address or a customer moves between various stages. And so you can spot things like, okay, X number of users logged in, added items to the cart, but never bought, and you can focus in on that. Or you can see that a lot of people are coming in, and these people are going and scanning a printer. You can hone in on those particular IP addresses or those particular users and drill down more into it. So it's a very effective way to visualize what people are doing and what the distribution is like across a flow. And while we have a lot of core analytics and advanced analytics around it, a very powerful analytics engine, we already have built a ton of content in the form of applications that is available for our end users. These are great starter content to get off the ground running. If you know you have an Apache, if you have Palo Alto Networks logs, Sourcefire logs, operating system logs, there is a lot of content, a lot of interesting monitors and searches available for you to get up and running very quickly. So with that, I want to change gears and talk a little bit about how we use Sumo at Sumo. So we are running a very large system, collecting a lot of data, analyzing a lot of data, and we are barely 2.5 years into the market, and this is tremendous scale. And we are growing at a very rapid pace, and this scale will only grow bigger over the next 2, 3, 4 years. So in order to provide this service at this scale, with the high performance and high uptime and high availability, we need to make sure that we have very, very good visibility into how the system is behaving at any point of time. And we provide the system that provides the service actually today consists of 2,000+ nodes that we run in Amazon Cloud. We collect a lot of data. We generate, the numbers are actually very, very close to 3 terabytes of log data every day that we generate and we collect and we analyze. And we run a shadow system that collects all of these log data, and we feed other development systems or performance testing system logs in this shadow system. But this shadow system is our eyes and ears into how our production system is behaving. And so our philosophy is very simple. We want to instrument everything, every application, every cluster, every assembly, instrument everything, and we monitor from a customer perspective key performance indicators. So when you walk into Sumo Logic development engineering teams where they said there are a couple of TVs that show the key KPIs, the key performance indicators, and they can go green or red. And whenever something turns red, you can immediately dive in and try to determine a root cause, do a root cause analysis, figure out why it happened. Once you figure out why it happened, then you can turn it into an alert. So whenever that thing happens again, you can get paged and you can react to it very proactively. So it reduces the MTTI and MTTR because now you get very real-time notification and you can build playbooks around it to respond very actively. And again, one thing that I'm a big fan of is peace for the paranoid. I mean, operations folks, site reliability folks, and security folks are always wondering what's going on that I'm not looking at. Right? And that's where the anomaly detection kicks in, because not only with monitoring, you are looking at things that you know you should be looking at, and you have this catch-all engine that will detect events that you didn't know you were looking at. So this is a sample set of KPI dashboards that we run. There are about 16, 17 of those, and whenever one of those turn red, we can drill down right from that into the search, and all the log data is there. And we can analyze it, we can do forensics, we can figure out exactly a timeline of what happened. And that provides this tremendous amount of agility to provide a lot of really good operational insights and helps us keep the service running with good performance and high uptime. And with that, I'll pause here and hand it off to Abhay to talk a little bit about how he's using and his team is using Sumo Logic at Netskope.
Good morning, everybody. Can everyone hear me okay? Great. So good morning and good afternoon, everyone. It's a pleasure for me to talk about Netskope and our use of Sumo Logic today. I'm going to take just a few moments to talk about who we are, what is Netskope, what we do, and then jump right into our use case and how we use Sumo Logic. We are a cloud security company, and what we do is we allow large enterprises to discover and control cloud SaaS applications. We do that through our Netskope Active platform, which provides real-time and granular control of cloud applications. As you know, the amount of cloud apps that enterprises are using is exploding, and there is a real need for such a solution. And we do that better than anyone else in this space. We also do something that is unique to us, is to provide contextual visibility, wherein if you are using a particular application, a cloud storage application or a CRM application, we actually can find out exactly what a particular user was doing by looking deep inside the transaction that is happening between the user and the cloud application. And when we do discover these things, we provide a rich set of dashboards and metrics and trends that both an executive in the CIO's office can use to track trends of his organization, of their organization, or a network or a security administrator can pinpoint a specific interaction that is potentially risky and pinpoint that. We also have a rich database of thousands of cloud applications. Some of them you see here on the screen, on our UI screenshot, which allows an enterprise to understand the risk of using those cloud applications, whether they are compliant, whether they do encryption at rest, they have audit logs and admin controls, and so on and so forth. And you can use the criteria that are important for you to find out how risky these applications are. And we also provide very rich visibility of data as the data passes through our cloud solution, our cloud proxy solution. And we can answer questions like who is sharing certain content with a cloud storage application, or who is uploading PCI. And once you do that, you can also set policies that are extremely granular, that says do not allow a person to share sensitive documents outside of your organization. And we do that through our cloud-based product, the Netskope Active product. So without further ado, let's get to the topic, how we use Sumo Logic. And Kumar gave a fantastic overview there of Sumo Logic. So I'm going to piggyback on some of the things that he mentioned. But before we get there, why did we use Sumo Logic? Just to answer that question, we had a few use cases that we really wanted to find an answer for. We wanted to track usage of the Netskope platform. What are customers doing with our product? Where are they coming from? What are the kinds of things they're seeing or running into? And what are the key areas or the hotspots in the application that our customers like and visit often? And obviously, we want to do that across our customer base. So that was the first use case. The second use case was around application performance. I mean, we are running an application that large enterprises trust us to provide real-time security for their mission-critical applications. So we want to track application performance. We want to track application throughput, bandwidth, and the kind of activities we are doing, so that we can not just be up and available and performant, but also plan for growth. We can see a trend line ticking up, and that allows us to do, that provides an input into capacity planning as well, which I think is a great use of Sumo Logic. And finally, application errors. The dashboard that Kumar mentioned, we have something similar at Netskope. We not only track application errors on an aggregate basis, but also as a real-time alert, and we'll talk about that a little bit more. So just a quick overview of our network infrastructure at Netskope. We have thousands of servers across the globe hosted in our own data centers. We use the Equinix co-location facilities. Each server, virtual or bare metal, has a Sumo Logic agent deployed, and we'll talk about what did we do to help simplify the Sumo Logic agent deployment and the way the collectors are configured. And we did that using something called Ansible. Ansible is a automation framework tool, just similar to Chef or Puppet. And this allowed us to really, when we deploy a particular server, no matter what the server is, we can push the Sumo Logic collector to it, configure the collector, and have it up and ready without having to do any manual tasks. As you all know, in the world of cloud applications, you have to bring up servers and services in a matter of seconds. So automating log collectors for Sumo Logic was a big part of our server bootstrapping process. We also did certain things with Sumo Logic, which Kumar, I don't think, talked about, but I think are very important, is to allow, when you configure these collectors, Sumo Logic provides you the ability to do first partitions. So you can create a partition, and I'll explain what that means. And also, it allows you to extract certain fields automatically. What the partitions do is a very robust way of doing role-based access control. So, for example, people, as everybody knows, a compliant organization has division of responsibilities within their operations team, so that not a single person can see everything going on. By using partitions, you can create partitions for, let's say, EU or Europe, or specific countries within Europe, so that only the specific people who are cleared to have access to those regions have access to those regions. The field extraction rules allow you to create categories so that you can detect regions and data centers. We are spread across many data centers across the globe, as the next screenshot will tell you. And it is actually very important for us to be able to say, where is this error happening? Why is this happening? Is this happening across all data centers for that particular service? Is it isolated to a particular region or data center? That gives us the ability to move traffic off of the errant service, so that our customers do not see any impact to their service, or to the Netskope service. So one quick thing that you'll see throughout my deck is just a quick advice. I'll advise you to design your collectors, sources, source categories, field extraction rules, and partitions. Take time to do that, because that will be extremely helpful when you scale out, when you are scaling across data centers, when you're scaling across regions and countries. It's extremely important that you have this very well designed. So I talked about first use cases to track our customer or user behavior, and one of the things we did, as Kumar said, developers instrument their code to log messages, and with messages we log certain anonymous statistics. Which URL was visited, by what anonymous user ID, and whether they logged in, or the login failure, or did they see a 200 error, or a 404, or 5xx. And those instrumentation we use to run certain queries in Sumo Logic to aggregate these statistics. And we also run daily reports to kind of gain some customer insights. To find out what did an aggregate group of customers did over a period of day. This is actually very important for us to track. An extremely important statistic for all cloud services is how are customers getting value out of your solution. And we want to make sure that all customers are logging in and making sure that they are getting a good experience and they're getting the value that they wanted out of Netskope. I want to show one very quick way of seeing some of these things. You obviously want to build your custom dashboards and aggregate queries and so on and so forth. But Sumo Logic provides a variety of applications, as Kumar mentioned. We at Netskope specifically use the Nginx and Apache application. We use Nginx in various different configurations as a load balancer, as a SSL terminator in some cases, in various different configs to do handoffs to lower level services. And the Nginx application from Sumo Logic is really an excellent way of gaining insight. When you drag that application or you install that application and provide it the right category to search for, it goes off and provides this fantastic overview dashboard, which is great for someone in my position looking at where are people coming from. As you can see, we are getting customers from pretty much all over the globe, all the continents. You can see how many successes and failures you're having. How many redirects do you have in your code? Where is the traffic going to? What servers? What server pools? Is it load balanced across the servers properly? And the volume of the traffic and the number of hits. So you can, if you have a spiky period, like most security products tend to, then we can actually analyze what the customer experience was when certain things just spiked up high. So this is an example dashboard that shows some of the things that we see for a particular set of service or one service, I guess. I really like this Nginx visitor locations dashboard that Sumo Logic provides, and it not only shows across the globe where are people coming from, but you can drill in to specific countries, and you can see that we are getting a lot of visitors from, for example, Europe and US, and also in India, where we have a development team. In the US, you can see that we're getting lots of people from Northeast and the West, Northwest, as well as the Southeast. You can have divisions based upon users in different states, and you can also then have drill downs into specific countries. You can see where people are coming from various different countries. This actually is an excellent tool for you to plan for your data centers, and if you want to be as close to your users, this will be an excellent guide for you to track where you're going to get the lowest latency and how should you plan your data center expansion. For example, in the previous chart, you saw that we started to get some users from Australia, and that will be a key factor into our data center expansion plans going forward. Another bit of information is what browsers are people using, their PCs or Macs, or the unknown platforms could be your monitoring agents. Like we use a variety of monitoring agents to track external network performance, and we go into a deep inspection. So we see that as well. We see that a large amount of our user base is coming from Windows, but Mac is not too far behind. This is another good example of really making sure you're prioritizing the right kind of testing when you're testing your application. So clearly, Firefox is an important browser for us by looking at the browsers, and so is Chrome. Whereas Internet Explorer is not so important. We don't see a lot of users coming from Internet Explorer, even on Windows these days. So these are key trends and metrics that you can use to really create inputs into your engineering and operations teams for a variety of different aspects of your operations, as well as engineering deliverables. We also use Sumo Logic to understand application performance and throughput. And just like Sumo Logic, Netskope platform is also built to analyze large amounts of data every day, different kinds of data, not the semi-structured data that Kumar talked about. It's about network data. And we also perform various different transformations of the data before it is provided to customers, because we do lots of visualizations ourselves. And we obviously built a pipeline of the way the data flows through our data center. Tracking the analysis pipeline, making sure things are not falling behind, making sure we have enough headroom for growth is extremely important for our customer experience. And we have built an excellent array of dashboards by using our instrumented logs and using Sumo Logic queries to really predict what kind of performance are we going to see if the load on us is, let's say, 10 times more than what we are seeing today. That allows us to scale systems proactively, that allows us to be a step ahead of anticipated customer demand, allows us to do capacity planning. One key, again, is make sure that your developers instrument their code for measuring time taken, and you do that in a consistent way. You want to have entry and exit points for key functional areas within your application instrumented, so that you can find out what time is taken and you can trend that. You can also build a KPI around how long certain things are taking and how long they should take. That will allow you to do analysis of various parts of your stack. You could analyze, for example, whether your data store is performing correctly, or whether your service is having a performance issue doing certain types of analysis. These are again good practices to follow when you use a Sumo Logic query-based analysis system for your backend. Tracking application errors and exceptions. So obviously, developers are prone to emit all kinds of errors and exceptions in their logs. We at Netskope we took upon an effort to make sure that things are standardized. Even though Sumo Logic can really handle all kinds of formats, we really want to standardize on errors and exceptions so that there are certain metrics that we can easily pluck out from different services, even without having to build custom queries. And we did that. Sumo Logic also does interesting things if you emit statistics in a statsd type of format, where statsd has a name value pair type of format. If you do that, then Sumo Logic can extract that information and allow you to chart that to find out where your code is having errors or exceptions or bottlenecks. One key ability, as Kumar said, is the real-time queries that Sumo Logic has. You can set up a query to look for a particular error or exception and send notifications in real time, so you can see whether a particular error has happened in a key part of your application. And this is in addition to all the other monitoring systems that you might have in your cloud. You might have a Nagios or a New Relic or one of those things. But in addition to that, having such a thing is extremely important, because a log message will have way more detail to analyze and track the actual error or exception. And then finally, KPIs. So you want to build a dashboard that shows the error volume, and obviously that has to be as small as possible or be zero in many cases, and that's what you really want to do, so you can actually have trending information of your errors and the volume of errors, and you can use that for continuous improvement. You can track your 500s or you track your 4xx and see what are errors versus what are expected values, and really go about reducing that volume and keeping an eye on that going forward, so that no new errors show up as well. with that, I want to, I guess, transition back to Asta. And Asta, you want to take over?
Yes, thank you, Abhay. We will now begin our Q&A. Please continue to submit questions via the chat window. We have one question. First one goes to Kumar. How does Sumo Logic scale to support each customer's compute and storage requirements?
So, as you know, for storage, we use S3 very heavily, and that is the ultimate destination for data at rest. That said, and in S3 we are using different buckets, different keys to encrypt every customer's data. The keys get rotated every day. So there is a logical isolation between all the data at rest. So that's about the storage part of it. For the compute part of it, we are a multi-tenant service, right? So we have, the architecture is very different and very, when we started the company in 2010, we started this as a service. So we built it like many of the larger scale services you might be familiar with, Google, Facebook, and many of the consumer sites, they run in a very multi-tenant mode. So what that allows us to do is to efficiently provision infrastructure to handle the workload. And we have several hundred customers now, and when one customer is peaking or one customer is using the service very, very heavily, the other customers might not be banging at it at the same time. So we end up seeing a much more efficient use of infrastructure at the same time. So we have a lot of architectural component built in that can scale up and scale down and route the workload to a variety of servers depending on what the current load is. We also have some guardrails that we put in between, from one customer impacting another customer. And so you can burst, but you only burst up to a certain limit. And we do the capacity planning in a way that we can handle those bursts that happen.
Great. The next question is for both Abhay and Kumar. Looks like Netskope monitors security of all cloud applications. How does Sumo fare, and how does it protect its service?
Yeah, so great question.
I'll let Abhay take this one, and then I'll chime in a little bit later.
Sounds good. Thanks, Kumar. We use, we built our cloud service, again, as Kumar said, our cloud service is a multi-tenant service. And, we use our logs that we generate. We use Sumo Logic to aggregate those logs to run queries and perform various actions on it. What Netskope does is very different from what Sumo Logic does. We actually are inspecting real-time traffic as it passes between the user and the cloud application, and we built a custom, engine that understands traffic going between the user and a particular application. So those are two different things. The way Sumo Logic helps secure Netskope in many ways, and I didn't show this, is also by looking at anomalies, like what Kumar was talking about, of users coming in. We can track what clients are facing errors. Are there scannings or bot networks coming and trying to find our service or try to exploit a weakness if they have not found one. So those are all the techniques that we use from Sumo to protect our own service. Kumar?
And to add to, yeah, that was an awesome answer to that question. And I'll add a little bit of how we protect our own services, right? So to add a little bit color to that, we believe that security is best done in depth. It's like defense in depth, right? So you have to apply a variety of tools to make yourself secure, all the way from how you design the architecture, how you encrypt the data, what kind of operational practices you have, do you follow, principle of least privileges, are the various assemblies segregated enough so that if one gets compromised, the impact is going to get limited. We do a whole lot of penetration tests and fixes that we make as a result of those. So the security for any cloud service, and Sumo Logic in particular, we take it very, very seriously, right? And we take it at the architecture level, we take it at the operational procedures level, and we take at the, from an external perspective, how the service is doing. We take all of those very seriously. And our internal procedures are very, very stringent to make sure that, that all the customer data is secure, and we are following the best security practices. And we have gotten a ton of certifications, security certifications done. Many of our customers will do their own security certification audits on the service, and we have been very successful with that practice.
Asta, just to quickly add on to that, I want to just add on to that last point about certifications. Netskope is also a compliant organization with SOC 1, SOC 2, Type 1 and Type 2 certifications, which are the standards of cloud security companies, and I believe so is Sumo Logic. So when we work with other application vendors, we make sure that they are compliant. And I think using Sumo Logic and your use of your compliance with those standards was extremely important for Netskope.
Great. And the next question is again for you, Abhay. I'm going to combine two questions. It's around why did you choose Sumo Logic over some of the other offerings in the market, and what were your challenges, if any, as you adopted Sumo Logic across the board?
Great question. Well, I'll take the first part. Netskope is a startup. We're a small company. And the obvious advantage of Sumo Logic when we started a couple of years ago was the fact that we did not have any local footprint of Sumo Logic. We didn't have to maintain an index server. We didn't have to maintain a server that did databases for aggregations. We didn't have to prune the logs ourselves. So all the advantages that you can get out of a software as a service deployment mode was the first immediate lure for us to use Sumo Logic. And then as we started using Sumo Logic, the LogReduce functionality was very important as you're building a new service, and we literally were doing code pushes before we went live with our version 1 of our application. We were doing code pushes literally daily, and we will find problems. The LogReduce functionality helped us do a lot of find the needle in the haystack kind of thing, and that was very important for us. The second part of the question, what did we encounter? What challenges did we face in deploying Sumo Logic? I would say some of those things that I mentioned in my slides. One is instrument the code properly, make sure your logs are consistent so that you can track things across services. We kind of learned it. Second is organizing the collectors. Very important if you want to build queries using source categories and regions and data centers. And third thing is just the deployment of the collector itself. We wanted to make sure that we did it in such a way that it can be bootstrapped immediately. So I just go back to those three things that I mentioned in my slides about some of the lessons learned and some of the things that I would like other Sumo Logic customers to do as well from the get-go.
Great, thank you for that, Abhay. The next question is for Kumar. What are the examples of anomalies that Sumo Logic can uncover in a typical DevOps environment?
Great question. So I'll give you a couple of live, real, out from the field examples that we have discovered with customers. In one case, there was a misconfiguration that someone applied, which essentially took down half the cluster, and it didn't go fully down, right? Because the other half was functional. So some people started seeing failures, but not everybody was seeing failure, and people they actually didn't know about it till about 4 hours. And one of the things, that was one thing where they didn't have anomaly detection running, but we also have a historical mode of anomaly detection. So where you could go back and say, hey, run anomaly detection over this period and see what you would find. And if they had that running, they would have gotten a real-time alert because it clearly picked that up. It was such a strong signal. And they have a lot of monitoring. They are actually one of the more advanced customers of ours. They have a ton of monitoring. And yet, there is always a new code push, a new code path that gets introduced, that gets exercised. There is a new error failure mode that happens. And you can't possibly monitor each and every possible failure scenario. So while it's good to, and that's why I think monitoring, I start from the customer's perspective. What are the key performance indicators? Drill down further and further on. But from a bottom-up perspective, anomaly detection is very, very key. Another examples are simply like, when some of the services that you're dependent on, if the service starts having an issue, what we start seeing is certain kind of log volumes start going down. And even if it's not impacting a KPI, but a certain kind of functionality changes or a certain kind of functionality stops working, we have seen anomaly detection pick those up and give you a proactive alert about those.
Great. I think you almost answered the next question, which is about, will I be notified about every anomalous event? How does Sumo Logic reduce false positives? Do you want to add something there?
Sure. So I think, so you can use anomaly detection in 3 modes. One is, I used a screenshot of live dashboard. I talked about you can do historical. You can go back and look at some of that data. And whenever we find an anomaly, we generate an internal event. So we generate an event and pipe it back into an anomaly detection engine. And so you can turn any kind of, turn that into an alert, turn that into a monitor. And so yes, you can get, you can monitor it, but you can also get alerted on it. And reducing false positives, I think that's where a lot of, it's very easy to build an anomaly detection engine that is good for a demo or a POC. It's tremendously hard problem to actually make something that works on real data with all different kinds of data sources out there. And I think it's fair to say that I think we probably have the most advanced engine in terms of anomaly detection engine out there in the market today. And we are continuing to invest quite a lot of R&D into further improving that anomaly detection engine. In fact, the engine that we had 1 year ago has been completely revamped. And the beauty of a software as a service is you don't even realize, you just see that the quality starts improving over time. And it's a work that we continue to invest in.
Great. We have time for just one more question, and this is for both Abhay and Kumar. What pre-built dashboards and applications do your organizations use on a regular basis?
So many, go ahead, Abhay.
Sorry. Well, I think we use a variety of those, Nginx, Apache, and various different devices that we have in our network. I can't mention all of those, but we use quite a few of those application dashboards.
And on our side, I think Apache is one of the ones that we use. We use the security application quite heavily ourselves. PCI is another one that we use quite a lot. And from my personal, there are different groups and departments, like our CISO and VP of security. She uses the PCI, the security analytics apps, much more. The sales team also uses our service for looking into customer insights, but those are many of the custom applications and custom dashboards that we have developed. But security ones are the ones that we primarily use out of the box applications here at Sumo.
All right. With that, we'll conclude today's webinar. So thank you very much for joining, and we will be sending you a thank you email with the recording of the webinar. And as you see on the slide, you can also sign up for a fully loaded free 30-day trial at sumologic.com/signup. If you have any follow-up questions, please feel free to send them in through the email that will be going out to you shortly. Thank you again for joining, and we'll see you next time.
Thank you.